This video response is going to go out to Danica McKellar, and that's because I'm going to continue my review of your book entitled Math Doesn't Suck. And we're going to review Chapter 7 today. And you were talking about sharing and siblings. Well, let me tell you something. I have two older siblings, and when you're talking about sharing, it does create a certain amount of sibling rivalry. So it's like, okay, we're already starting off kind of on a bad foot here, but okay. Anyway, I was kind of wondering, why do you keep referring to food items to illustrate mathematical concepts? There are other things that, especially girls, girls and young ladies, they do actually share besides food. And I can give you plenty of illustrations on that. They share perfume, nail polish, clothes, secrets. Just kidding. But there are plenty of other things besides just food that these people share. I mean, it's great that you want to use food as an illustration for some of your stuff, but I wouldn't so heavily rely on it. I'd figure out some other thing to share. Okay? You could even share bracelet beads. I mean, haven't you ever... I know some young ladies do this. They take these strings and they have these beads and they put them on there and they make little bracelets out of that. Maybe they share yarn. I just did a video a few minutes ago about somebody that was crocheting something. They could share the yarn, whatever. See what I mean? So there are other things you could use for illustrations besides just food. Just a thought. Alright, now when I'm thinking of the greater than and less than sign, I'm thinking of a one-way sign. Have you ever driven down a road and you see a road up ahead and it says one way and it points to one direction or the other? That's how I visualize greater than or less than. And the way I visualize it is like, well, the one way is pointing towards the slum area of a major metropolitan area. Okay? So, and it would always be pointing to the major slum area of a metropolitan area. And that's because of the visualization of seeing a slum area. Okay, that's probably the least place you could ever be in a city. And the visuals on that would be enough to remember that particular visualization. You want to go any place other than the slum area of a major metropolitan area. That's so visually stunning you would never forget that. Okay, so, alright. Now, when you're dealing with smaller fractions, what you can just actually do, like I said, when you're dealing with smaller fractions, you can pull this off. Bigger ones, it's a little more complicated. But if you're dealing with a smaller fraction, let's see. Fraction I want to deal with. Let's say you have Let's say you have 3/5, which is less than 5/8. How do we know this for sure? Well, what we can do, and this is real easy to remember. It may be complicated in multiplication, but it's really not that hard to remember to do this. You can take that 8 right there, and you can multiply 3/5 by that 8/8. Okay. Now the same thing can be done here. You can actually take this 5 right here, and you can actually multiply it over here. Well, if you do that, hello everybody, whoever you are, I am running a live stream right now. I apologize in advance because I am actually running a live stream, so that's why you're seeing me at an angle here. Okay? But anyway, if you do this, you can do this. You can see that 24/40ths is less than 25/40ths. Now, one of the things you could have done, which would have made it just as easily obvious here, is that you could factor out a 4 from 8. And this could have made it not completely obvious, but it could have made it a little more obvious to you. You could have said 12/20ths is less than 25/40ths, which wouldn't be it wouldn't be entirely visible like this, but you could kind of get a sense that this one is definitely less than this one. Of course, you could, like I say, you could just do it the way I showed you originally, but you could do that. Now, you did illustrate one other way to do this. I agree it would work, but the problem in doing this is if you had to suddenly change the fraction to a decimal, then you run into some problems. But if you didn't have to change the fraction into a decimal and you were just trying to compare something, that wouldn't be so bad. But anyway, let's go ahead here. What you can do is what they call cross multiplication. Usually when you do cross multiplication, you make sure that the two values on either side of the equation is equal. You don't usually have a greater than or less than when you're doing cross multiplication, but you could do it. You multiply 8 times 3, you get 24. And if you multiply 5 and 5 like that, you get 25. Okay? And definitely 25 on this side is greater than 24 on that side. So yes, it does technically work. And you can actually see the logic on this, because when we multiply that 8 times 3, isn't that exactly what we did over here when we had the 8 over 8? That's exactly what it was. Okay? But, like I said, even though you know which value was greater than the other, the only problem with that is that if you actually had to translate this out to decimals instead of fractions, because you'd have to divide the numerator by the denominator, then if you're not used to doing fractions, that could be bad. So it's a little word of advice to those people who take this easy little shortcut. And the shortcut may not pay off in the long run. Okay? And that does concern me a little bit, and I did not see that in your book. I did not see a caution that says, hey, you know what, this trick will work, except if you're going to have to eventually turn those fractions into decimals. Then you got a problem. Okay, so it's just a thought there. All right, so those are my thoughts on Chapter 7 of your book, and we'll see what you think. All right. I will tell you more in a future video, so I'd like for you to stay tuned.